Thanks, Mike. So hello and welcome to the session about VSE Connectors. I'm giving you a little introduction in what the VSE Connectors are, what you can do with that, and how to use it best. So my name is Ingo Franzki. I'm part of the CVSE development team since many years. And I probably have met some of you already in person at some conferences, so maybe you know me already. And I, of course, hope to see you again in person at some point in time when the situation has changed. So maybe we can then meet at another conference. All right, so then let's get started. So VSE Connectors, what is it? Well, basically the VSE Connectors started as a single function at the VSE ESA 2.5 a long time ago. And at that point in time, we started to build the Java-based connector. Well, the basic idea was to kind of replace the distributed workstation feature that some of you might still know, which was based on personal communication file transfer and having a graphical user interface to interact with VSE. And we wanted to bring that on a new level, TCP/IP based and more modern technology. So the base idea was to bring something to life like the VSE Navigator that we have today. And as part of that, the Java-based connector was created and was brought to life back then. Well, since then, as you can certainly see here on this timeline, many VSE releases have been made available. And in every VSE release, we added something to the connectors. So it kind of evolved over time. It changed from a single function to many different functions, many different connectors. So it's not one connector that we provide, it's really a set of different options, and you can choose which one you want to use. You don't have to use all of them. You can just pick and choose which one fits to your needs best. So with that, we of course are supporting the CVSE PI strategy with protect, integrate, and extend. Well, and the connectors obviously play a role for the extend thing here. So it allows you to extend the use of VSE within your distributed environment. That certainly consists of different systems, not only VSE, but other systems are certainly part of your environment. So if we look at the full picture that you should see now, you see a lot of boxes and things. I'm not going to talk about all of them here on this slide, so don't worry. But it kind of shows the variety of connector solutions that we have available. Well, not all of those places shown here on the slide are provided by VSE. Some of them are just provided by other products, like TCP/IP itself is very important for the connectors. Obviously, well, CICS plays a huge role, DB2, and things like that. As you probably also see on this slide, all the communication between the right side, which is the VSE side, and the left side, which is a Java-based platform or remote platform. So all the communication between all of these parts are mainly TCP/IP. That's the way to go nowadays. So, well, SNA, you see it, I think, once on this chart, but other than that, it's all modern TCP/IP based communication. Well, back then when we started, TCP/IP was pretty new in VSE. Well, nowadays, I would guess that most VSE customers use TCP/IP anyway. So the CVSE connectors are part of the CVSE product. They are fully supported as part of the CVSE license. And most connectors consist of a VSE part and a distributed or workstation part. The workstation part are also distributed as part of the VSE system in wbooks in prt2.prod. So they are also serviced through APARs and PDFs, but you can also download these workstation parts from the CVSE homepage. It is the exact same level, so the level that you get from the download page is always the very latest APAR level that you would also have in the system if you have installed that APAR. Well, the CVSE connectors, which are part of the VSE system, are a set of connectors, but there are also a lot of tools around that make use of these connectors and show you how you can use that. Well, these tools are provided as is. That means without official support, in contrast to the connector components which are part of the VSE system, but those are fully supported. So they all can be found on the connectors web page that you see on the right side, and you have the link on this chart. So, for example, the VSE Navigator that I mentioned earlier can be downloaded there, as well as all the connector components. Also, the Knowledge Center contains a manual called the eBusiness Connectors User's Guide, which is kind of the Bible for the connectors. And the link that I provided here is a good starting point for learning more about all the connectors. So as part of this presentation, I will go over all or at least most of the connectors. But before doing so, I want to kind of sort and arrange these connectors so that you understand what they can be used for. And I have separated them into 3 different scenarios. So the first scenario would be that you want to web enable or mobile enable your existing CVSE applications. So if you look at this scenario, well, on the right side of this picture below, you have the back end, which is the CVSE system, well, one or multiples of them. And within that VSE system, you certainly have some data. Well, typically VSAM, maybe DL1, maybe DB2, maybe some other data, maybe sequential files. And you certainly have batch processing working on this data. And you have transaction servers like CICS regions, where your online users work with and access the data and manipulate the data by that. So that's your backend, certainly existing since a long time and working well. And in order to web enable these applications, you will need a middle tier that you see here in the middle of this picture. Well, this middle tier typically runs on a distributed system. It certainly can run on Linux and IBM C. That would be, from a performance point of view, the best place because it is close to VSE. But it can also run somewhere else on any server that you like, Windows, other Linuxes, other Unixes, whatever. Typically, you would need Java. So wherever you can run Java, you could run these middle tier systems. And part of this middle tier would be web application servers or portal servers or other kind of presentation servers. For mobile enablement, it would be kind of a mobile application server. You would also might have directory and security services sitting there. Now, towards to the left, there might be some edge servers like firewalls or load balancing servers that would be at the border of your company to either your intranet or to the external internet. And somewhere in that networks, then your end users are located, being it your clients accessing your services through a web browser or through a mobile device, or being it your in-house customers accessing this service through the intranet. So in this scenario, you can then web enable and mobile enable CVSE applications. Typically, those applications would run in the transaction servers under VSE, under CICS. And by doing so, you can kind of modernize the user interface for that applications, make them accessible through web browsers, and building new features by that way. You can also web service enable your applications, like you provide RESTful APIs for that applications to build microservices in combination with other services that might be available in your system or in your environment. So this is the first scenario, web and mobile enabling of applications. The second scenario would be to have a central database, or at least to have the data that is important to you at a central place where it can be accessed from many different applications and services. So for example, if you want to do analytics or business intelligence with the data, this data needs to be accessible to these systems. You might want to put your data somewhere in the cloud. You might want to analyze it through Watson or through whatever other business intelligence and analytics solutions that you could think of. So the dream of many VSE customers nowadays is to kind of move all the data from VSE into those central database, being it a typical SQL type database. Well, this sometimes remains a dream, simply not because it's totally impossible, but simply because from a performance point of view, moving data out of VSE is not always the best solution. Well, we all know that VSAM and also DL1 is really fast. So you can imagine that if you move that data outside of your VSE system and access it through a network, it can only get slower. So nevertheless, the connectors are there to help you. And the connectors, for example, provide solutions to synchronize data between VSAM and a database that you could then use for doing analytics or things like that. We will go into the details into that too. The third scenario that I'm gonna think of is modern VSE administration, operation, and automation. Well, automation especially is very important. You want to automate as much as possible, so that you don't have to have some people available pressing the button every time. You want to automate that. You also might want to use graphical tools for VSE administration to make it easier for your administrators to use your VSE system. And we also provide tools like the VSE Navigator or the CICS Explorer or the Health Checker or Keyman or many other tools that allow you to do that. The connectors also can help you to do automation, and by that I especially mean cross-system automation. So within VSE, you typically use Rex or other scheduler products to do the automation, but you might also want to involve other processes that are outside of VSE into your automation. Well, think about you would need to take a backup of VSE data and a database that sits outside of your VSE system, and this backup has to be in sync. So you probably want to automate that when you take a backup, that both backups are taken at the same time and that they are in sync. So this is what I mean by cross-system automation. It becomes more and more important the more systems play a role in your environment. All right, so with that, those are the three scenarios I want to mention, and now I'm going to go through all the connectors that we provide. And you can see on the right top side of the screen which scenarios these connectors apply to. Now, of course, this is not a very sharp way that they apply. You can always use one connector also for other things, but these are at least the typical scenarios that we think they apply to. So let's start with the Java-based connector. Well, Java-based connector was, as I mentioned at the very beginning, the very first connector. It provides remote access to VSE data and programs from a remote Java program. So that Java program runs somewhere on a Java platform outside of VSE. That could be a Linux on IBM C, or it could be a Linux on Intel, or it could be a Windows or any other system where you can run Java. And well, on the VSE side, you would run a CICS Connector server, which accesses all the data that is available in VSE, like VSAM datasets, DL1 data, library members, ICCF members, but also power to submit jobs and get listings, and you can also issue console commands and many other things. On the distributed side, on the Java platform, we have a Java library that can be used to access these VSE resources using a very simple Java API. Now, you can use this simple Java API to build standalone applications, like we did with the VSE Navigator. The VSE Navigator is a graphical front end for VSE that allows you to, well, look at files and copy files by drag and drop and things like that. It's just a standalone Java application that uses the connectors under the covers to do all that. You could build your own application if you like, or you could use the VSE Navigator if it does what you need. The Java-based connector can also be deployed into web application servers or mobile application servers so that you can write, well, servlets, JSPs, mobile applications, web service enable them. So this connector can be deployed as a so-called resource adapter into these web application servers. For example, into IBM WebSphere application server, but also into other J2EE-based application servers. Same is basically true for any kind of mobile application servers, being it mobile first server or anything that runs in Java and supports J2EE resource adapters. And with that, you can build your applications, again, either standalone Java applications or web-based applications going through a web application server, structures and access VSE data remotely. Well, that access is in real time, so you don't get a copy or anything, you just access the data right at the time. You can read the data, you can of course also update the data. Well, if the permissions allow that, you could set up security so that not everybody is allowed to update your data, of course, or even read your data. So security is in place, but you can set it up that way that your applications can get to the data that they need. Right. The next connector I want to show you is the VSAM Redirector. Now, the VSAM Redirector now plays a role into the second scenario with having the data in a central database. The VSAM Redirector provides a synchronization of VSAM data with a database. So if you take a look at the picture as it is shown right now, you might have some applications running on VSE, either batch applications or CICS applications, doesn't matter. And they use the VSAM access method to access VSAM data and updating the data, reading the data, whatever. So now when we add the VSAM Redirector into that picture, there are different modes that the redirector can operate. The first mode would be a real-time data synchronization. So how does that work? Well, as part of VSAM, there is an exit that gets control when an application performs VSAM requests to the VSAM dataset. Now this exit kind of can route it based on a configuration to the VSAM Redirector client, which itself can route this request to a remote system, to the VSAM Redirector server sitting on the remote system. And there the request is passed to a so-called handler, and the handler can then translate that into a request, for example, to a database. So that basically means that VSAM request as done by the application is intercepted and forwarded to the database. And this all is totally transparent for the application. The application still thinks it does VSAM requests and it continues to do VSAM requests, but under the covers, we can do something in addition to it. Now for real-time data synchronization, for this mode, we only intercept any VSAM requests that change the data. So namely insert, update, and delete will be intercepted, and the data will that way be kept synchronous with the database on the left side. When the application just reads the data, those requests do not get intercepted, so the data is just read off the VSAM dataset. So that way you keep the database in sync with the VSAM dataset. Oops. So the second option would be a real-time data migration. In this case, all VSAM requests are routed to the database. So that VSAM dataset that is still there on the right side, it's basically empty. It's still there because it is needed for open and close, but it really doesn't contain any data anymore. So all the data requests goes to the database, which means you write to the database and you read from the database. So that's why it's called data migration. You kind of migrate your VSAM data over into a database. Now, the third option is a near real-time data capturing using the VSAM capture exit. Now here, we, instead of going in real time to the other side, we capture all the changes that an application does to a VSAM dataset, and we write these changes into a so-called delta file. This is just another VSAM file where we write the changes to. And this is relatively quick. And then from time to time, you can load these changes that have been collected in the delta file into the database using the redirector delta loader, which then feeds the data into the database. And then the database is in sync again. Well, as you can imagine, the more often and the more frequent you run this loading, the more near real time it is. If you run this loading just once a day, well, then it's not very near real time, obviously. But it is up to you how often you run this delta loader process. Well, and finally, as part of the VSAM redirector, you also get other loaders that allow you to do a full load of a VSAM file into a database. Well, this is required for the initial loading. Once you set up this thing, you have to initially load all the data from the VSAM file into the database, obviously. But you can also use that to just make a copy of a VSAM dataset into a database that you use for other things. Well, I know customers running those on a daily basis just to kind of make a copy in the database that they use by other means. Now, as you can imagine, intercepting VSAM requests and routing them to a remote system has a performance impact. And depending on the mode that you use, this impact is, well, larger or not so large. So let's have a closer look onto the modes of operation of the VSAM redirector. Well, on the very left side, the data migration mode, which means the data is no longer in the VSAM dataset and all the access requests go to the database. This gives you real-time access to the data in the database. But obviously, because you redirect all the requests, this has a quite high performance impact. VSAM is really fast. So you can imagine if you replace that very fast VSAM by a network operation and a database operation, it can only get slower. And well, the performance impact is really not too less here. It really has a high performance impact. So because of that, it's certainly not something that you can do with all your VSAM datasets and all your applications. This would simply be too slow for you. But for selected applications and special cases, this might still be a way to go. Typically, batch suffers much more from the performance impact than online, because batch is typically running sequential processing, and therefore it simply adds up easily. Now, online access is typically just single requests, not that many in a time, so therefore the performance impact might be okay. For the data synchronization mode, the one in the middle, the performance impact is not as high as for the data migration, simply because only the update requests are replicated to the database. The read requests are untouched and go directly to VSAM and therefore are fast, but all the updating VSAM requests have the same penalty. So depending on your workload, if you have a batch process that updates each and every record in a dataset, well, then the impact is also high. If you have a workload where just a few % of the requests are updating requests, then it's certainly okay to run that. If that data synchronization overhead is still too high for you, then you can look at capture and apply. Well, capture and apply also has some performance impact, but it's certainly the lowest of all those three, simply because it just writes that record that are changed into a delta file. And well, that's just another VSAM IO. That's not too much overhead. And the replication from the delta file into the database can run asynchronously. You can control when this happens, and it runs totally asynchronously and block your online applications. Nevertheless, the changes are not real time anymore. They don't appear in real time in the database. This has certainly the lowest performance impact. All right. The next connector, CVSE database call level. This also plays a role in the central database scenario. So imagine you have a data sitting somewhere in the database in your environment that's not inside VSE. So a database server running on Windows or Linux or wherever, and you want to access this database from your VSE applications. Now you might remember VSE offers a DB2 client edition as part of the DB2 server offerings. And certainly with the DB2 client edition, you can access client databases being DB2 databases. However, what if you have, let's say, Oracle or Microsoft SQL Server or MySQL or whatever database that you need to access? Well, then the database call level interface can be used to that. It basically allows you to have a VSE application, batch or CICS, that uses the DBCLI API to invoke database services through a middle tier, through the DBCLI server running on a middle tier, through the database's JDBC driver to the database. And because the JDBC driver is a standard, it basically can access all kind of databases. So it doesn't really matter whether it's DB2 or Oracle or Microsoft SQL Server or whatever. As long as the database provides a JDBC driver, it can be used. And by that, you can have SQL type access to any kind of database that sits somewhere in your environment. Now, I mentioned it already, DB2 Client Edition provides you basically the same functionality for DB2 databases, but only for DB2. And then it would be the DRDA protocol shown here. But of course, the DBCLI can also do the same thing. But not only for DB2, but also for other databases like Microsoft SQL Server, Oracle, MySQL, whatever. As long as you have a JDBC, you can integrate that into the database connector. The other databases could certainly also be accessed somehow by using DB2 Federation, using the DB2 Client Edition. But I really would recommend to use the DBCLI API to do so and not Federation. It's a very complicated setup, and yeah, I think DBCLI is much easier. Now, the DBCLI, the database connector, provides an API that you can use in your applications to access these databases, but it also provides an interactive query tool. So without doing any programming, you can just run that in a terminal, and you type in the server name, the user IDs, the database name, and so on. And when you press enter, you get to the next screen. It connects to the database, and you can then enter an SQL statement that you wanted to be executed. You press enter, and it executes that statement and, for example, shows the results of that statement. So this is something where you can easily, from a terminal, access such a remote database through the database connector through DBCLI. The same thing is available in batch. So if you prefer to run your queries in batch, you can do the same thing from a batch job. Just have some statements like connect, and then you can issue your SQL statement that you like, and at the end you disconnect. And when you run that little job, it would produce an output which looks a little bit like this, and it would have the result set of that select statement in this example in the listing. So that is kind of the same functionality as the interactive terminal, just through batch. And of course, you can also use the programming API to integrate that database access into your application. All right, so far about database access. Now, CICS Script Connector is another connector that we provide. The script connector can be used to access VSE resources from non-Java applications that run outside of the VSE system. Well, remember the very first connector that I showed you, the Java-based connector, provides remote access to VSE resources for Java applications. But what if your application is not Java? For example, if you would like to use Microsoft Office and scripting within Microsoft Office to access to VSE data, like getting the addresses of some letter recipients from a VSAM dataset or something like that. Well, Microsoft Office doesn't really like Java, so what could you do? That was the idea for this connector. So we provide this VSE Script Connector, which acts kind of like a proxy. So instead of implementing all that VSE resource access, well, in whatever Microsoft Visual Basic or .NET or whatever, we decided to have this proxy solution. So from that Microsoft Office or non-Java application, you can call a script that is located again on a middle tier server. And from that script, that's a little programming language, a quite simple scripting language, you can then access VSE resources in a very simple way. You can get the data and pass this data back to the Office application or to the non-Java application. And by that, you can integrate your VSE data even in non-Java applications. Well, you also have a command line client where you can do that, run a script from a command line. And you also have the possibility to call such a script from VSE itself. So we even have a VSE script client running in batch or in CICS inside VSE. So now, why would you want to run a script on a distributed server started from VSE? Well, certainly not to access VSE resources, because you could access them directly since you are within VSE, but the script server also allows you to call or run external processes on that distributed server. So that gives you the possibility to do kind of a remote execution. You start a script on the VSE system, and on the other side, it starts that external process, like a database backup or whatever that is. And it waits for completion, and you get back all the output it produced and the return codes and everything like that. So you have full control over the execution of that process from within your VSE application. And that could be used for automating cross-system that I mentioned at the very beginning already. So you sometimes have to synchronize processes and when they run, and when one is finished, the other one can start. So this can then, for example, be used to integrate external processes into your already existing VSE automation using recs or scheduler products or things like that. All right, well, next topic, CICS connectivity. Many of you are probably using CICS to run your business critical applications, to drive all your terminals and all the terminal-based applications that you have. CICS actually is much more than that. It provides very good communication and connectivity features as well. Well, the base of the CICS connectivity is CICS Web Support. It is the interface for TCP/IP into the CICS. And based on this CICS Web Support, we have different solutions that can be used. So let's start at the very beginning. CICS Transaction Gateway. This is a chargeable product, and it allows you to have an application running on a remote platform calling a CICS program within the CICS region. So it's kind of an exact CICS link from remote. You can pass a COM area, you call the program, and the program can return back a COM area. And this all from remote. Well, CICS Web Support also has a 3270 mapping engine. So for 3270 or BMS map applications, it can automatically turn that into web-based applications that you can view in the browser. Well, CICS Explorer also has a backend that runs as part of CICS Web Support. so it uses that one as well. And then we do have the VSE provided connectors like the REST support and the SOAP support. Well, this is also based on CICS Web Support, and I'm going to talk about that in a minute. Well, additionally, you can use Host Access Transformation Services, HATS, to access applications running in CICS or in generally on VSE. Now, this does not really go into CICS. Instead, it uses the Telnet 3270 data stream, wherever that comes from, and turns that into a web-based application. Certainly works with VSE, but also works with any kind of 3270 screens, wherever they come from, VM or COS or wherever. Okay, let's now concentrate on the RESTful Web Services and the SOAP-based web services. Now, SOAP Web Services support exists since quite a while in VSE. I think it was VSE ESA 2.6 or so where it started. And it allows you to web service enable your existing CICS applications. Web service just means it's kind of a callable service that sits somewhere on another platform. Now, with that, you can either provide existing CICS applications as a web service to the outside world. So imagine somebody else from outside, from a system somewhere in your environment, wants to call a service that you provide as part of your system, and this can then be done through a SOAP web service. Additionally, it supports that you, as a VSE application, can call external web services, which are external to your VSE system, so running on a server somewhere in your environment. In this case, VSE would then be the client. So this is also possible. Yeah, there have been some enhancements in VSE 6.2. We added channels and container support for that, for SOAP to be able to process larger amounts of data. Yeah, if you want to learn more about those features, please refer to the connectors manual that I mentioned at the very beginning. RESTful Web Services, this is quite new. This allows you to provide existing CICS applications as RESTful web service to the outside world. So similar to providing SOAP-based web services to the outside world, you would now provide RESTful web services to the outside world. Well, REST kind of got more and more used in the industry, and SOAP kind of no longer is used. So REST is the way to go nowadays. The REST support also allows you to call or use an external RESTful web service that is provided somewhere else. So you can call that from within your CICS applications. RESTful web services typically use JSON payload, just because this is where it originally came from. The JavaScript world was using REST since a long time, and therefore JSON is very popular, but it's not limited to that. RESTful web services can also have XML payload data or binary text or plain text or whatever. So all kind of data is possible with REST. So what is REST? REST stands for Representational State Transfer. Now, don't ask me where this name comes from. Anyway, REST is a software architecture style. It consists of guidelines and best practices to create web services. So it's not a standard per se. It uses lots of internet standards under the covers, but REST itself is not a standard. It is being used more and more in the industry, kind of replacing SOAP-based web services simply because it's much simpler than SOAP. REST basically just makes use of the HTTP protocol. So it uses that protocol, which is also used by web browsers all over the time. So it just uses the existing protocols to communicate or to build web services and let applications talk to other applications. Typically, a RESTful web service operates on an object on the server. So that object could be anything, could be if you have a bookstore, the object would be a book. And the object is typically addressed through the URI, which is part of the URL that you see here. So it typically has kind of a hierarchical order of the objects, but this is not necessarily the case. And it uses the typical HTTP request types like get, put, post, and delete to operate on that resource. So get would read the resource, put would update or replace it, post would create it, well, and delete obviously will delete it. And you can, of course, specify additional parameters through the URL query string, as you see in the colored line below. Typically, RESTful web services are stateless. That means each request from a client must contain all the information that is necessary for the server to serve that request. So the session state and anything that a client needs to remember needs to be held in the client. The server does not keep any state from request to request. It just executes each request as its own. In all these definitions that I stated here, the term typically kind of means that this is best practices to do it that way, but you can also do it differently. So I have seen RESTful web services that do maintain a state. Well, if it makes sense, then you can do it that way, but typically you would not do that. So let's have a little closer look into what VSE provides as part of the REST support. Now, VSE can act as a REST server or as a REST client. As a REST server, we do have a program running within our CICS system that provides some useful thing that we want to provide as a RESTful service to the rest of the world. So somewhere that's going to use that service will be on the left side, coming through the network, coming through CICS Web Support, and hitting the REST server. That's part of the VSE operating system that we provide. Now, this REST server takes that request, looks at it. If the payload is JSON or XML, it parses it, and it then kind of parses all the requests, looks if it is correct and things like that, and then passes that information within a COM area defined block to the program that runs the service. And well, that service can do anything, return some data back, and the REST server then produces the response and sends it back to the client. Very similar if VSE is the REST client. Here, a RESTful web service exists somewhere in the network on a server on your system, and you have a user program running inside CICS in VSE that wants to use that service that is provided by someone else. Now here, your user program simply calls the REST client through an execix link, passing some information through the COM area, and the REST client will then create that REST request, sending it out through the HTTP client to the web service. The web service replies with some data, and you get the data back in your user program. All details about all that can be again found in the eBusiness Connectors Users Guide. There is a link below here which gets you right to the pages that are relevant for that one. All right, another connector. It's kind of not really a connector, but it's more like a security feature. But since it communicates with other servers, I also mention it here under connectors. LDAP sign-on support. You probably know that when you want to access VSE systems, you have to log on. Well, at least this is the way it should be. So you have to supply a user ID and a password, and this is then checked by the VSE system against the currently active security manager. Could be the basic security manager, or could be an external security manager. And if you supply the right password, you get in and you can use the system. The same is probably true for your workstation. When you start in the morning, you have to log in and you have to supply a user ID and a password. And most likely that user ID and that password is different from the VSE user ID and the VSE password. just simply because VSE user IDs are most likely 4 characters. Now, on your workstation, you probably have much longer user IDs. Also, if you access any corporate web applications, you will have to sign in using a user ID password. Now, since it's hard to remember thousands of different passwords, you would of course wish that you could use for all these applications the same user ID and the same password. And this is exactly what the LDAP sign-on support allows you to do with VSE. So instead of signing in with your 4-character VSE user ID and VSE password, you would then sign in with your corporate user ID that all the other applications also use. And under the covers, VSE would authenticate against your corporate identity management system. Now, identity management systems are typically LDAP based. Think about Microsoft Active Directory. That's really an LDAP server. But there are other identity management servers around there that do similar things. So by integrating VSE into that corporate-wide identity management system, you can have kind of a single sign-on solution. Well, you still have to sign in explicitly, but you at least can use the same user ID and the same password. And this also means if whatever an employee leaves the company and you remove that user ID from the corporate identity system, then that user can also no longer sign in through VSE. If they would still have access to it, probably they don't, but even if they would have, they could not sign in anymore because the identity management system knows that this user doesn't exist anymore. And you can also force password change policies or things like that because, well, simply the policies of your identity management system applies. Now, since the user IDs and passwords are certainly different from the one you use on VSE, there is a user mapping. So when you sign on, your corporate-wide long user ID is mapped to the 4-character VSE user ID. And from then on, within VSE, you run under that 4-character user ID. Right, finally, the very last connector that I want to show you here. Also not really a connector, but it has to do something with remote connections, so I'm mentioning it here. This is the SNMP Monitoring Agent. It provides a monitoring agent that allows you to monitor VSE systems using standard monitoring interfaces through the SNMP protocol. We as IBM provide a set of plugins that provide certain monitoring data on a very basic level, like CPU utilization, paging, some performance counters, numbers of SVCs and things like that. But this monitoring agent allows to write plugins and plug new functionality in. And this is available for vendors, well, also for customers, but vendors typically would write such plugins. And so did a company called Velocity Software. They wrote a plugin where they can monitor, I think, TCP/IP and CICS. And if I remember correctly, even in the VM workshop, we have a session from Rich Smirtsina talking about that solution. So if you're interested in that, look for Rich Smirtsina's session. So as a summary, you have seen that VSE has lots of possibilities to interact with remote systems, to integrate VSE into the rest of the world, into a distributed environment. No matter if VSE is the client or is the server, no matter where the data is, we have lots of possibilities to get to that data, no matter where it is, and to play a role with the modern communication like RESTful Web Services and things like that. So lots of possibilities, and I certainly didn't even mention all of them. So if you are interested in more details, the first stop would certainly be the eBusiness Connectors Users Guide. Or if you have additional questions, you can always reach me through email, We also have a contact form on the VSE webpage where you can reach the VSE team. So it doesn't go to any marketing folks, it just goes to us. And we can then get back to you and we'll talk about your questions. So with this, I am at the end. Are there any questions?
Ingo, thank you very much. And publicly thank you for your help in getting our connectors working here at the Supreme Court. We absolutely love them. Floor is open for questions. If you have a question for Ingo about connectors or something else, please unmute yourself and ask away. I've seen questions through the chat being asked and answered earlier. All right, Ingo, thank you very much.
All right. So thanks for listening.
Bill, I'll turn host back over to you.
Okay, did you want to stop recording?
I do. I think you need to make me the host again.
Oh. Somehow Bill Munson became the host. Yeah, it's showing Bill Munson as host.
Bill. Yeah.
The VM Workshop should be able to take it.
I got
There
it.
you go.